You can do that at the beginning of functions so that you don't have to say, I've got a table, I'm just declaring all of these methods in the table, now I'm constructing a class from that table. It was just a bit long-winded. So we did that. There are no commas necessarily needed if it's not ambiguous. And a couple of other tweaks to just make them a bit neater. The meta method stuff. I lost it, there we are. Again, just happens there in place, inside the class definition. I added another meta method called methindex. The reason for this being that I sat down and thought to myself, why does op_self exist? Given that it's essentially an op move and then an op get table. And I figured to myself that there must be a good reason for it to exist, and it's probably something like efficiency. And then I thought to myself, if I had a special meta method for retrieving methods, then op_self could use that, and it would be potentially more efficient, but more importantly, it would mean that you can't muck up a class instance by poking at it, because I get slightly worried about people poking at instances and messing them up. So I added methindex, which is used for looking up methods. It's backwards compatible, so it calls methindex. If that fails, it calls index. Well, if that fails, it looks in the table. If that fails, it calls index. You get the idea. And I added a doc and a setDoc meta method, so that classes can aggregate and redistribute their documentation for all of their member functions. There you go. I knew I had one somewhere. Very simple example of class. As you can see, the syntax is simply class, string, class name, table of methods. That is then processed by something that gives you scary closures. You can actually, right now, there, you can add parent classes, interfaces, and other pragmas associated with the class, like you can state that it's abstract by saying abstract at that point. Abstract classes aren't allowed to be constructed. Does anyone have any questions about the class system very quickly? Otherwise we'll cover them at the end. No? Good.
Yeah, there's 4 minutes away.
4 minutes away, yep, I'm rushing now. Other syntax changes. C and C++ style comments from Dan East, and then a whole bunch of stuff from Ricky, table comprehensions, for loop augmentations, and what he calls satisfaction expressions, which are a bit strange, and we'll cover them in a moment. Table comprehensions, an example of how Aranha isn't afraid to take good ideas from other places. Consider the Python statement, keys is key for key in dictionary. That's what Python call a list comprehension, and it's Haskell calls a list comprehension. I apologise. I'm not old enough to know Haskell. I thought it'd be nice to be able to do that in Aranha, so we did. I said to Ricky, comprehension's a good idea. He went, yes, coded. They're valid only in table constructors. They start a bit like a for statement. They have a yield section instead of a code chunk, and then they end. For example, keys is for key, comma, something in pairs dictionary yield key. Bit more wordy than Python, and presumably a lot more wordy than Haskell, which just probably uses a pling or something. But I feel the right way round. Rather than expression for variable list in iterator if condition, you get for variable list in iterator yield a bunch of stuff. Yield comes in two forms, list style yields like we showed before, and map style yields where you can yield key equals value back into the table. In fact, any valid field that you could put into a table constructor, you can yield out of a comprehension. So you could yield closures of over values that you've iterated, and then your head explodes. But you can do it. Limitations of constructors: once you reach the yield keyword, you can only yield one or more fixed at compile time elements to the constructor. I say compile time, I mean obviously byte compile, not Aranha compile. So the syntax is, if you yield A, B, C, you will always yield 3 values for each iteration. So to get around that, Ricky went, oh, and extended the for loops. We have when, while, for, and for. I'm only going to cover one of those, but I'm very happy to show examples to other people. Essentially, when expression says that the body will only be run if that expression evaluates to true. While expression says that the iteration will only continue while that expression is true. For, another for loop, is a sub-iteration. So you can go for I in list A, for J in list B, do something, and for is a co-iteration. So you can iterate two things at the same time, which makes zip, which is a little Python function that zips two lists together. Really, really, really easy. A couple of very simple comprehensions for you. The first one extracts all of the even-numbered elements from a list. And the second one extracts all of the key value pairs from the environment where the value is a number. Woo! I can even read them. Satisfaction expressions are a little bit stranger. They take the form variable list equals expression list satisfies expression. The variable list can be used in the scope that contains the satisfaction, and the expression evaluates, the entire satisfaction expression evaluates to the value of expr. This can be used with ifs, whiles, and whens. So you can say if result comma message equals some function satisfies OK, then bunch of code. It's a bit like that. It's a nice little way of getting some extra, combining a local variable statement and an if. So OK and message are local variables inside the scope of the if, rather than outside the scope of the if. It's a very Ricky thing, and I don't fully understand them. In the future, I intend to integrate with LuaJIT, or rather integrate LuaJIT into Aranha. I'm almost there with that. It's quite scary. Now your pages are not only bytecode, but actually assembler. Caches. If you end up finding the Aranha wiki, then you'll find large documents about code caches. 5.1 pure module support, some standard modules, fix bugs, and anyone who comes up with any good ideas for me today. I will take questions, but I've just got a very, very simple demonstration here running on my local machine. On the left you can see a page running, on the right you can see the source code to that page. So that one is just proving that pure HTML can still be processed by Aranha safely. If we follow it through, grind, there we go. There's an example of a file ending .lua rather than .lhtml, so that's code with embedded HTML rather than HTML with embedded code. You can see it just sets up a couple of variables and interpolates them into the document. Ka-ching. There's a little example of everything that comes in with Aranha. You can define functions even if you're doing code embedded in HTML, and you get quite a lot of stuff turning up in your initial environment. You get the fast CGI environment that's come from the web server, and any parameters that turn up afterwards. There aren't any in this example. Simple forms that work. So if we put my name in, you have to be Jeff to carry on the demonstration. So you can do, obviously, any kind of application you want within there. So, any questions? Hooray, you're all stunned into silence.